Okay, next up we've got color subtraction, and this is the harder one. This is an A level usually, and it is harder just because there's a lot more thought that goes into it than the colored shadows. So this is what I call the actor's clothing problems, and this is where we're going to have to figure out what color object and what color filter will create a certain color of light that we see. So I'm going to do an example. And again, sorry that everything's in the same color, but that's what we've got. So a typical problem I will give you looks like this. You'll have a triangle with 3 colors. You'll have another triangle with 3 colors, black, black, and blue. And to distinguish between black and blue, BK, I'm going to use black. B is always going to be blue. And then I'm going to have a big question mark box here, a big question mark box here, and then 3 question mark boxes here. So the way the actor's clothing questions work. So we have an actor wearing a shirt and a leg. So they have 3 different colors of clothing on them. And the shirt in one condition looks red. The shirt in another condition looks black. This leg in one color filter looks green. Under another color filter looks black. So it's the same orientation. This is the same color as this, or this is the same object as this. These 2 are the same object. These 2 are the same object. We want to know what color filters we're going to use to create this, what color filter we're going to use to create this, and what color each of the 3 objects of clothing really are. So you have 5 things to answer in an actor's clothing problem. You have to tell me what color filter this is, what color filter this is, and what the 3 colors of clothing are. You will never have a piece of clothing that is black, so you'll never have something that's black here, and you'll never have a white light here. Your answers are just the 6 main colors that we're doing. Red, green, blue, the primaries, yellow, cyan, magenta, the secondaries. So those are the possible answers, both for the filter and for the different colors of clothing. So based on that 6x6 grid that we did in class, remember that the yellow, cyan, and magenta only show up one place. You will only ever see a yellow object if it's a yellow color, if it's a yellow object under a yellow filter, under yellow light. Same with cyan. You only see cyan if it's a cyan object, cyan filter. Magenta only if magenta filter, magenta object. So that's what I suggest looking for first is yellow, cyan, magenta, because if you know that, if you see that, you already know one of the filters and one of the objects. 2 out of the 5 are done. Now I'm giving you a harder one here. So this is a more difficult one because we have no yellow, nor cyan, no magenta, and we have 2 blacks. That can make things harder, but we'll just use logic to figure it out. So we can do this. So there's lots of different ways to do this. It's a logic problem. And I'm going to show you one way to think about it. If you solve these a different way, that's fine. So I'm just going to say, okay, there's no secondaries at all. So I can't, there's no yellow, cyan, magenta. What can I do? Well, all right, black, black, and blue. That's probably not going to be very helpful. How about this one? I see red, I see green, I see green. Okay, well, I see something that's red, and I see something that's green. That means that whatever color filter I have here has to let red through, and it has to let green through. Okay, so what lets red through and what lets green through? The only color that lets us see both red and green is yellow. So this must be a yellow filter because that's the only color that will let us see both red and green because red plus green makes yellow. All right, so I know one of the filter colors. Woohoo! Now here, okay, well, I'm going to see if I can figure something else out. Red looks black, green looks black, green looks blue. Hey, I look at these 2 and I say, this object in one condition looks green, but the same object in another condition looks blue. That means this object contains both green and blue. So this has both green and blue in it. The only object that has both green and blue in it would be a cyan object. So this object has to be cyan. All right, anything else? Well, okay. Now, I'm thinking about this yellow, and a yellow filter subtracts out the blue. Can I do anything with that? I know there's blue here. So yeah, the cyan object, this filter just blocked the blue and left us the green. Not very helpful. Okay, what else can we do? Well, the only color we're seeing is blue, so it's something that lets blue through. So something that allows blue to get through, a filter that allows blue. And the red object, this whatever object up here has red in it, but the red part of it isn't showing. So I know this filter must subtract out red because I know there's red and it doesn't show up. Similarly, this object, if we have yellow light, it looks green. So I know there's green in it. And if there's green in it, but now it looks black, that green must have been pulled out, absorbed, filtered. So I know that we're allowed to see blue, but the green and the blue and the red, the green and the red are blocked. So what color filter could this be? Well, the only colored filter that's going to let blue through but block both the red and the green is blue. It's got to be a blue filter. It lets the blue through, but the red and the green, we don't see anything. All right, we're getting there. So now we have the two filters and we know this is cyan. We have to figure out what color this object is and what color this object is. So up top, red and black. So we see red. So it has red in it. There are three colors that have red. It could be red, it could be yellow, which is red plus green, or it could be magenta, which is red plus blue. So we know there's red in it. It has to be one of these three. So could it be red? Sure. Okay, fine. Yeah, so because if it was red, would the blue filter make it look black? Yeah, it would take out the red. Could it be yellow? Okay, so could this object be yellow? No, it can't, because if this was a yellow object, it would have looked yellow under a yellow filter. So it can't be yellow. Scratch that. Could it be magenta? So could it be red plus blue? Well, okay, the red gets blocked here. It can't be magenta, because if it was magenta, it would be red plus blue, and it would have looked blue here, because the blue would have shown through. Can't be magenta. So this, I just did totally the wrong thing. This is a red object. There we go. So the actor's top is red, and we know this leg is cyan. We're left with just one. Okay, we know it has green in it, and that makes it look black. So it has green in it. There's three colors that have green: green, cyan, and yellow. Okay, could it be green? If it was just green, well, yeah, it would look green there, and the green would get filtered out here, so it would look black, so green's good. Could it be cyan? Well, cyan is green and blue. If it was a cyan object, the blue would get filtered out, it would look green here, we're good there. And if it was a cyan object, it would be green plus blue. Nope, because it should have looked blue here, so it can't be cyan. And same as the thing up here, it can't be yellow because it would have looked yellow there. So that's what we have here. Have we answered the question? Yeah, we have all 5 boxes filled. And does it make sense? Again, problem solving, the best thing you can do to get the right answer, to pass a question, I guess, is to stop and check your answer. Does it make sense? So does this make sense? If this is a red object, under a yellow filter, the red should get through. Yep. A red object under a blue filter, there's nothing there, it should look black. Yep. A green object. Okay, green object under a yellow filter, green gets through. Green object with a blue filter, green gets filtered out, it looks black. Cyan, which is green and blue. So cyan under a yellow object, the blue gets filtered out, leaving me green. And cyan under a blue filter, the green gets filtered out, leaving me blue. It all makes sense. So that's the process for going through one of these actors' clothing problems. Now, there are other ways you can do it. I just chose one way that made sense to me at the moment. If you asked me to solve this tomorrow, I might solve it a different way. I don't care how you solve it, so long as you can come up with the answers that make sense, that are logical given the data that you have. So that's the process for doing an actor's clothing problem. So that's an A-level. And this is color subtraction as opposed to the colored shadows, which is color addition. So that's what we got. Good job.